So thank you so much to the organizers for arranging for this get-together, also for the right upon the sad news get-together where people shared their feelings and everything. That was very special, and I was so emotional at the moment that I am extraordinarily thankful that I was able to collect my thoughts and my feelings and share them with you on this occasion. So I want to tell you about my experience with Rohini, and I understand that it was long ago that we collaborated, and perhaps the science we did, for me it was very exciting, but it's not the most insightful and up-to-date one. So I want to focus on sharing with you how I saw Rohini as my first mentor in research, and later on as a companion for many activities for women in science. So I met Rohini in 2012. Back then I was a first-year master's student in KTH Sweden, and I just had the funny thought that I should do something useful with my life over that summer, and that something useful should be physics. So I just, I asked Google, who are great theoretical physicists, and I tried to search for them and see who had reported on their webpage to take summer students, and I just emailed like 70 professors, and I waited in front of my computer thinking at any point I'm going to get so many offers back. So one person responded, and that was Rohini. She was like, "Do you want to work? Come, I give you work." So I surely came, and she basically only asked me, "Okay, what was your favorite course so far?" And I said, "Quantum mechanics." She said, "Great, we will do some quantum mechanics." I came here in 2012 for the summer. I had a fantastic summer. I learned a lot. I enjoyed a lot. I was very surprised by the country. I made great friends in the department. I know it was a very short time, but it was so intense for me. By the time it was time for me to go back to Sweden, I only know one thing, and that was I still have no idea what I'm doing, but I'm coming back. And Rohini was extraordinarily helpful. I really don't know why she decided to open time to help me with a lot of paperwork that was required, because it turns out that me coming back to write my master's thesis here under her supervision implied opening a full new bilateral agreement between Sweden and India, and I would not have been able to do that on my own whatsoever. This is a genuine copy of the something that was called, it was funny, it was called final version _now_yes_27. So to give you an idea of how committed she was to have me back, I have no idea why. And we worked together. So I don't want to be exhaustive about it, but I want you to understand that she was always very careful what my interests would be and how to make me network. So for that, I need to walk you a bit through the idea of the project. So the idea of the project initially was very, very modest, because she believed, okay, let's see how far you can go, you little thing. Okay, you came all the way to India, that was okay. Now in physics, how far can you go? So first things first, there is this thing called the Frost bound, and it's very universal, it's very deep, it's very fundamental, it's an upper bound on scattering processes of any two incoming particles, and at high energies, it sets the rate of speed to log square of the center of mass energy. So can you reproduce that? And so I did. It was not that hard, because I found some lecture notes that were extraordinarily detailed, but I walked through everything. And then she insisted that I should be able to appreciate unitarity. Really, it was a profound guideline, and we had many discussions regarding what is absolutely crucial in physics and how unitarity. I remember she said, if you have to believe in a God, then it should be unitarity. That impressed me a lot. So back then, and I really apologize because I don't remember the name of the person who was around here. I think he was a young professor in RRI or something, and I don't remember his name, really. I know he moved on shortly afterwards to the US to become a professor. Thing is that he was an expert on ADS-CFT, which back then was kind of a hot topic, and we had some talk here, and I had shown interest to Rohini, and she said, "Oh, this is a great opportunity. Now you go and talk to him, and you get a master course on ADS-CFT. And so I did, and I came back so overexcited. Oh, but that was so interesting, Rohini. She said, yeah? Okay, now you have a job. Look, there is this paper by Giddings, and he derived the Fraser bound using ADS-CFT correspondence. And as a reminder, this is just a strong weak duality between a theory of gravity in the bulk, ADS, and in the boundary you have a CFT, one dimension less. So look, if you put an ADS metric and you look at the weakly coupled regime, you perturb it and you create a black hole that will give you a upper bound on the cross section of the scattering process in the CFT on the boundary. And with not small tricks, you can actually correlate the two things and get a Fraser bound out of it. So now you do that calculation as well. And so I did. But it was not gratuitous that she was pointing all of this. She was listening to me, what I wanted in life, what was my interest. She was networking me. But she also had her own ideas, I think it was bugging her that she had been using in some fits to the data, some correction term to the Fraser bound, and she was very disturbed that there was no good reason to add it other than the fits were better. So not so secretly, as soon as I was done with reproducing the calculation of Giddings, she told me, okay, you are going to do perturbation theory on that and you are going to get the subleading term, and I want to see if it is the one that I keep using with my colleagues. And yes, indeed it is the case. Let me very briefly walk you through the entire calculation so that you see it was spanning really different areas. And so we collaborated also with Onindosina, who is professor here, but I have not seen him around. So basically the calculation is a reproduction of the Giddings calculation, but instead of considering just the Einstein-Hilbert action, we perturb it with a small coupling with the Gauss-Bonnet term, exploiting some recent work by Professor Sina and his student Kololsen, who in fact were able to understand this correction term as accounting for 1/n corrections with n the number of colors. And I was made to add further terms in order to explicitly check, which in my master's thesis took something like 20 pages, that 1/λ corrections are genuinely extraordinarily suppressed, so you don't need to worry about them, and string corrections are also even more suppressed. So this is our leading order source of correction. Then you have to solve for the equations of motion following from extremization of this action, for which we use the solution ansatz where we place an ADS-5 background metric, and we perturbed it with some conveniently normalized perturbation, such that here you see a Z appearing, that's the radial direction in my ADS space. And in order to break the conformal invariance that it's very annoying for us, we introduced just an IR cutoff by hand. The ADS-5 background satisfies Einstein's equations for some negative cosmological constant. And the IR, as I said, breaks conformal invariance and gives the leading correction to the full picture, so that on the boundary we are ultimately going to have something that wants to look like QCD with very large n. And bear with me because, of course, we had no hopes of ever properly giving an explanation for the subleading term, but we wanted to see if we could find some insights, if it could be there somewhere lingering. I'm absolutely sure, because she insisted a lot, that n equals 3 is not large, and that it is not reasonable to assume nothing is going to happen between the Planck scale and whatever data was available at the time. So I think it was a combination of her wanting to establish if that term was purely ad hoc or there could be we could find some insight for it, and at the same time I think she was extraordinarily flexible because I had started like strongly diverting away from the original project. We placed the source on the infrared brain of the full picture, in fact, and then we had to add an incompressible gas for tracelessness of the entire source equations of motion. The point mass is ultimately going to be the source of the black hole and the way in which we are going to get an upper bound on the scattering process. And we placed Neumann boundary conditions as befits the gravity side of the entire story. So you see A and B include the Z radial direction, whereas mu and nu are the usual for space-time dimensions. Good. So we solved the linearized equations of motion, which, as it turns out, ended up being like a lot of heavy math again. And I took another funny detour, and she made me talk to some other collaborators of her, because there appeared some Bessel functions, and I was, again, very interested about that. And so I took a long detour, which spanned something like 30 pages in my way too long master's thesis, just blubbering around some properties of Bessel functions I was very excited about, and that they appear as you try to solve those equations of motion. Don't worry, because I collected as many poles as it takes to properly establish that only the first pole, J11 here, is going to be relevant. And this is basically what my solution looks like to the linearized equations of motion for this action under this ansatz. So you see I'm taking the perturbation in an attempt to collect the 1/n corrections to the Frazor bound. And as I said, this mass source term was introduced precisely so that then we could look at the limit when the mass would be high enough that our perturbation would be of order 1, implying the breakdown of perturbation theory, and implicitly, and as Giddens hand-wavily argued, I don't think that was very well established, the creation of a black hole in the ADS, whose geometric cross-section would provide an upper bound on the scattering cross-section of the C-broken FT on the boundary that was our large N version of QCD. And lo and behold, we of course reproduced the term by Giddens of the Frazor bound that we knew we would have. We had precisely the term that Rohini was seeking as a leading correction, and we had a next to leading order correction, log of times log, something a bit esoteric, but this is what came out. And we had 2 predictions, and we were very happy about them because this part we were not expecting. The first one is that if you trace the entire calculation in glorious detail, you will see that beta here is quite a big and generous and scary looking prefactor, but it's definitely negative. There is no other way. And there is also a ratio between the leading order Frazor bound term and the next to leading order, and that is minus 1/4. And that was quite interesting because at the time there was some other people suggesting it should be minus 1/2. So Rohini was like, okay, that was enough math and enough blah, blah, blah for you, and now look at the data. So she gave me so much data from so many experiments, and I had to compare all of that. So it really worked a lot, you know. When she said, do you want to work, come, I'll give you work, she was really serious about it. I can promise to you that I was tortured through various different starting points for the data so that we would carefully avoid the resonances and yet be sure that, all the fits were pretty reasonable. So I'm showing you one of about 10 million graphs that I was made to generate. We also took cosmic ray data because she was saying that was the only way to go into the future. And unfortunately, we can not do any better. At that time, we could not do any better than to bear with these big error bars. So lo and behold, Professor Joshi was also called to my rescue to make sure that I was not doing some random stuff. Turns out I was not, thankfully, because he was calling the picture after I had done a lot of work already. So I would have really been in dismay and late for my master's thesis if he would have found any mistake. So what you see, the fits here are basically a suitable adaptation of the terms that we had found. So you have, of course, the Frazor bound term, the leading order correction that we had found where we had predicted that C would be negative, The next to leading order, that we were hoping somehow is tailored to the Frazar bound through a ratio of -1/4. And the other terms are just to account for the low energy behavior. And you see here that the only difference between proton-proton and proton-antiproton is the sign of the last contribution. Rohini was very insistent that we wanted to have a universal characterization of both of the processes to try to really get to like the high energy universalizing or like single picture of the entire story. And we started playing the game if you really need those terms, if they provide a better fit or they don't. And just by eye, you can see that it doesn't seem like the next to leading order is relevant whatsoever, but clearly the fit is much better if you do have the subleading term. We made this precise using something called the F-test. I don't know if anyone is familiar with it, because I think it's some statistical resource that somehow is not so used in particle phenomenology. So in particular, I learned it from some biology books. Rohini loved the idea, and that's when Joshi was called in, and she said, "Oh, I love the idea. That sounds like exactly what you want." The F-test, basically what it does is it ensures that when you have an nested model, you are not just producing a better fit out of having a bigger parameter space, but rather it is relevant, exactly the functional form of the term that you are adding. So she immediately loved the idea. She said, "Can this project go more wild in more directions? I love it, but you're going to check with Joshi that you are not saying some random stuff." I wasn't. We did confirm in this manner that the subleading term was indeed very relevant. We couldn't establish at least with the data at the time, whether the next to leading order was necessary or not, even less ratify our -1/4 prediction. And well, years went by because when I finished my master's, I was seriously considering asking Rohini to please take me for a PhD. And before I even posed my question, because I feel like she really disliked, for some reason I don't understand, to say no to me, she just kept saying yes. Before I could even ask her, she called me to her office and she said, "What are you thinking of doing in your future?" I said, "Yeah, I'm thinking of doing a PhD." And she said, "Good, so you have to find a proper supervisor." I was very disappointed in that moment. I felt, is it because I didn't work well? I didn't work enough? Oh my God, for you. And she looked at me and she didn't ask. She just said, "Look, you don't like particle pheno, okay? That's clear. So you need to go and do your PhD somewhere else." And I've heard, many years back, I heard that she did put not only a good word through a very strong reco letter. She actually lifted the phone and said, you know, can you take this lady as your student?" I think something of the sort did happen. We remained in touch, though, because I started becoming very active in organizing different activities for women in science and fostering their participation. And I understood she has a very limited amount of time. But whenever me and my colleagues trying to put forward different initiatives would be genuinely all of us at a loss, I could always write to her and she would reply surprisingly fast. I say it. She basically never said no to me. Whenever she wanted to say no, she would prevent the situation from happening somehow. So she said yes when we asked her to take the opening speech for one meeting that we had, and I think that we had extraordinarily good lecturers for that occasion. It was streamed online with over 200 participants. It was very successful, and I really promise I'm not lying to you. After Rohini's talk, I was monitoring the chat. The chat exploded. We had to close it. We were about to lose everything. We received over 300 requests for the video of the talk. You can also request it now, and I have it with me, so I'm happy to share it with you. And for months, the fake email that I had created to just organize that kept receiving requests and praises, and I don't know, for Rohini's talk. It was absolutely incredible. Being a woman scientist, what helps and what hinders. It went on for almost 3 hours. She was scheduled for 1. It's a true pity that the last time that we were supposed to meet would have been this September. I was again organizing this time a science talk. I didn't want her to believe that I first and foremost don't see her as a physicist, because I do. And we offered her a plenary talk, and I can promise to you it was a doctoral school, and there were at least 4 professors who signed up just because they wanted to hear Rohini. And it was very sad for everyone that she could not join for health reasons. It gave me, though, the opportunity to Zoom with her a bunch of times towards the end, and that was really touching and very nice. In a sense, I got some sort of feeling of farewell, and that was very nice. I called my talk On the Trail of Unitarity, because I am still thinking about unitarity. So I changed field 3 times, or 4, I don't know. But the thing is that I keep thinking about unitarity. So somehow Rohini had it all figured out from the very start. And I'm just coming home to her first original thoughts for me. I'm also very happy that she's a unifying force of physics and also women in physics. And this, I think, meeting proves that remains the case, and I hope it will be for many years to come. Allow me for a short spoiler. We are preparing some special issue on the newsletter of so-called GenHead. It's an international gender in high energy theory working group based on, or hosted by CERN, but we are quite independent, and Genevieve and Abiram helped a lot put forward this. You should see it, just Google GenHead. It's coming out March 30th if everything goes fine, and the entire issue is dedicated to her. So thank you so much for having me here.